calculate the y dot KTs. If you remember, if you want to find the y dot KTs or the slope of this figure, we have some method exists that we explained to you. We have three methods. One of them you can connect these 2 points. You can find that this line, the limit is backward. One of them between these 2 lines, the limit is forward, or one of them between the first and the last line is a trapezoid method. That means you want to find the slope of this. That if you find a slope, you can find the y dot KTs. For find the slope, first of all, you can find this slope can change to this small slope, and they have an error between these 2 lines exists, but we can neglect these things. How can I find this slope? For finding the slope, we find the YkTs, that means the last value of here minus this value is a minus yk minus ts, divided by the distance is ts here. If you find the slope between this and this point, this one become YkTs minus yk minus 1 ts and divide by the ts. This name is backward. Or we can find this line too. This line and this line, they have some error, but we can neglect this error too. This is the green line, and this is the last values here is yk plus 1 ts minus YkTs divided by the ts, that the distance between here. This is the yk plus 1 ts, and here is a YkTs. Or you can find this slope. This have a error exists as such as before, but error of the trapezoid or the last method compared to the backward and the forward is less. In this one become yk plus 1 ts minus yk minus 1 ts divided by the 2 ts. Okay, and we put the name. The one of them is this one is all of them is a y that should be here. Backward difference, forward difference, and the central or the trapezoid is the same name. This is the 3 method to find the differentiated or y dot KTs. Okay, now we saw the one example, the application to emulation control design. Imagine you have the control system here. This control system is a k, s plus a, s plus b. The output become the input of my signals, and the input of control become the error. Find the differential equation to be programmed into the microcontroller using forward differential discretizations. Here I can tell you, you learn 3 methods to discretize of the S domain go to the Z domain. Okay. Find the difference equation of the CS, or using the discretization method, and rearrange the term to put the different equation in the desired form. Okay, how can I solve this problem? First of all, very easily, numerator of here multiply denominator of here, and the denominator of here will be multiplied numerator of here. You can extend it. And if you remember, u dot t, s us become u dot t, b us become b u t, and the ks es become k e dot t plus k a ET. That means I use the inverse Laplace to find the time domain. Now I substitute all of the t by KTs. KTs, t, KTs, and the t here is a KTs. Then, with the formula that you learn, u dot KTs, in the forward become u k plus 1 minus u k divided by ts plus b u k or KTs or k. Here they remove the ts is 1, or you can use a ts. And a k, ek plus 1 minus ek divided by ts plus a e k. Just use the formula that you learn is a y dot KTs you learn. Here you substitute the y dot by the u dot and you replace the formula of the system. Then easily just only simplify the equation. You will find the u k plus 1 will be this formula, and easily if you u k plus 1 or rearrange by the u plus 1, you can find the formula of the system. Another application, they said the GS is here, CS is here, HS is a 1. Then if you change the same method with the forward, backward, or the central or the trapezoid, you can see the difference between the analog and the digital. If TS, if you put the 0.1s, the digital and the contour have a big difference here. But if you change the TS a little smaller, then you put the TS equal to 0.01, you will see the analog and the digital will be overlap each others. This is the thing that you can see the between digital and the analog. Okay, comments about the emulation method. The discretization of the continuous control can be lead to a large overshoot than the expected if the sample period is large. This is very important. If a sample time that you saw is become 0, 1 or 1 or very big, you have a overshoot in the discrete time. Reducing the sample size is not always possible and will be increase a computation cost. And you cannot put the TS equal to 0.000001. This one, they increase the computation time and they increase the USB capacitor of the storage about all information. Possible solution. For the possible solution, tweak the parameter of the emulator control to improve the response. See the next slide we will see together. Design the controller directly in the discrete domain. How we can do this? Here between the analog digital control 1 and digital control 2, this is the difference between the two analog and digital. Okay, now the same example with remove the value and we put the A and B. With the same thing, we numerator here, no multiply denominator and denominator multiply numerator, we extend our the formula and we change in the inverse Laplace and we substitute t by the KTs and you find the UK plus 1 and substitute by the forward formula and you will find the equation about the UK minus 1, etc.